In the last segment of fuel cell 1.1, we have discussed already about the working and construction of fuel cells. Now, in this segment, we will discuss about the types of fuel cell. As you can see in this slide, the first type of the cell is the phosphoric acid fuel cell. It's a simple construction. Now, the simple construction is shown to you here. Here two different kind of electrodes, anode and cathodes is here, and there is supply of fuel in the form of hydrogen, and in the on oxygen supply in the form of oxygen or air at this inlet port and at this inlet port, and their external load provision here. So as we have already discussed, the type and the variety of fuel cell is based on the electrolyte used. What kind of electrolyte we are going to employ in our fuel cell, that certify or that makes it very particular. As in this case, this name of this type of cell is phosphoric acid fuel cell, in which phosphoric acid fuel cell is used as an electrolyte. Here you can see in between the electrodes. So working is very simple here. So what happen when here hydrogen as a fuel cell is used? When hydrogen as a fuel cell is used, hydrogen we are taking from at this point, and here negative ions, because this electrolyte is capable to make a movement of negative ions and hydrogen ion through it, from the hydrogen ions from anode to cathode and negative ions from cathode to anode. So this permitting the movement of this kind of ion, and we can say it's a non-conductive electrolyte. So this thing very important. If in any objective one who ask any question about the electrolyte, so keep this thing in your mind. This is non-electrical electrolyte, non-conductive electrolyte, but it permits allow hydrogen ions, the positive ions and negative ions through it. So the same is happening here, same is occurring here. Here the hydrogen ions goes to anode to cathode, negative ions goes to from cathode to anode. So simple reactions occur when the hydrogen ions react with electrons. Okay, the hydrogen ions, here hydrogen ion dissociated at anode, hydrogen ion dissociated at anode. As you can see here, the reaction hydrogen ion dissociated in hydrogen ions and electrons. So electrons is allowed to flow in external load circuit here from anode to cathode, and which is responsible to generate electricity. Okay, and the reactions which takes place at cathode is the here oxygen from air or oxidants which is being supplied here is react with react with hydrogen ions and form water and electron. You need to say yes, with the electrons and emissions used to produce water. So water, you are taking exhaust as an exhaust as like water and any some kind of exhaust. Same is here, exhaust fuel is going out at this exhaust port. Okay. Then second thing is very important. The working temperature of the cell is around 150 to 200 degrees centigrade. So that's very important. So at temperature that must be maintained. Otherwise, at very high temperature, this electrolyte is not capable to allow movement through it. So due to that, the heat dissipation is maintained. Heat dissipation is controlled with the help of its dissipated heat is employed for some other purpose of steam generation and other refrigerant or any hydromechanical cycle that can utilize this waste. And so it's very simple in construction and very efficient also. The next type of the fuel cell here. So next type is the molten carbonate fuel cell. It is MCFC. As you can see here the construction is similar to the previous one. Only difference is there. In place of hydrogen, we are using hydrogen and carbon monoxide as a fuel. Okay, and oxygen and air as an oxidant. Okay. A second thing, Here anode and cathode is similar way, but the only thing is that here in place of phosphoric acid we are using molten carbonate fuel cell. Okay, so molten carbonate fuel cell we are using here as an electrode, which is also capable to transform carbonate ions from cathode to anode. So this is very remarkable point. It is going to allow and is allowing to movement of carbonate ions from cathode to anode, and electrons in external load circuit from anode to cathode to generate electricity. So simple working is what kind of mechanism is occurring here is being used by this cell. Likewise, we can see here hydrogen and carbonates used. So simply what happened, anode reactions, I would first of all I am discussing about the anode reaction. So what happened when these carbonate ions when they reaches to anode, so hydrogen which are coming from the outside as a fuel, these carbon ions react with these fuels, they produce water and carbon dioxide as well as some free electrons. Okay, so these free electrons goes to this place. Okay, and here produce carbon monoxide, carbon dioxide is go as an exhaust, so we can take out from here, and some part of this gas carbon dioxide reaches to cathode itself. So cathode as well, and here the oxygen from air or pure oxygen is coming as an in the form of oxygen, then react with this carbon dioxide and the oxygen and remaining electrons which are being produced in the previous reaction here over here. So they just form the carbonate negative ions, and these only the main source of the generation of carbonate ions at cathode. As you can see here, the main reactions here is being displayed here over here. Okay, and the overall reactions that you can see here. In the overall reaction, this is again exothermic reaction, so we produce energy, chemical energy. Okay, exothermic reaction. Or second thing, the working temperature is around 650 degrees centigrade to 700 degrees centigrade. So again, it is very huge amount of energy is being liberated. So in order to utilize this exhausted energy or liberated energy, so many cycle like Rankine cycle and steam cycle heat engine that is used to exhaust energy for working purpose, and that working purpose may be generation of steam and running for a steam turbine and so many other things. So this is only the what we see in working of this kind of thing. And this is the next type of fuel cell, proton axial member fuel cell. So I think in the next segment we will discuss